Welcome back to our online lessons. So in this one we're going to have a look at rectilinear motion again, part 2, and we're going to find distance travel. So let's take a simple example. Say you want to travel from A to B and go back to A. So we're going to find the difference between distance travel and displacement. So if you go from A to B then back to A, your displacement will be 0 because you came back to your original position, but the distance traveled will be 100 meters because A to B is 50 meters, then B to A is another 50 meters. 50 plus 50 will give you 100 meters. But in this chapter we're going to use a formula to find distance travel, and the formula is integral of the magnitude of the velocity. So for this one you have to use your ClassPad calculator. You just have to type it in, the magnitude of the velocity on the ClassPad, and obviously you'll be given the time from where to where. So you'll have two limits, the lower limit and the upper limit for the times. So let's have a look at an example. Given x equal 2t squared plus 60 plus 10, find distance traveled in the first 3 seconds. Now to find distance traveled, we're going to use the above formula, which is d equal integral of the magnitude of the velocity. So first we have to find the velocity and then use the formula. So the velocity is given by differentiate the displacement function, which gives us 4t plus 6, and then we use the formula. So type this in your ClassPad exactly the way it looks. D equal integral from 0 to 3 because it's distance traveled in the first 3 seconds. So the limits will be between 0 and 3. Magnitude of 40 plus 6, and then use your ClassPad, and the answer will be 36 meters. Hence distance travel is 36 meters. So now let's take a look at the second example. A particle moves in a straight line such that its acceleration a meter per second squared after t seconds is given by a equal to t take 5. First up, find an expression for the velocity given the initial conditions. V is 4 when t is 0. So given acceleration, you want to find v, we have to anti-differentiate. So anti-differentiate 2t take 5, which will give us t squared take 5t plus c. And then we're going to use the initial condition to find the value of c. So when t is 0, v is 4. Substitute, solve for c, and c equals 4. Hence v will be t squared take 5t plus 4. Next part of the question, find the value of t. In fact, it's values, means you can have more than one value. Find the values of t when the particle is momentarily at rest. Now this is a very, very important word. You'll see that a lot of time in questions. So at rest means v is 0. That's all you need to know. So at rest v is 0. You already have the velocity function from part A. Equate that to 0, factorize, use null factor law, and find t. So t is 1 or t equals 4. Next part of the question, find the displacement between t equal 2 and t equal 5. So displacement, you can just anti-diff the velocity function between 2 and 5, but remember, no absolute value. It's just the displacement. So just type it in your CAS calculator and the answer will come as negative 3/2. Same question, the distance traveled between 2 and 5. So basically it's the same question. One is asking for displacement and the other one is asking for distance travel. So for distance travel we use the formula that we're doing today. So it's the magnitude of the velocity from 2 to 5. Use your ClassPad and that will give you 31/6. So compare your answers in part C and D. They both travel between 2 and 5, but the answers are different. That's some food for thoughts. Hope you enjoyed the lesson. So now you should be ready to do exercise 3C. Thank you.